Welcome to the Open Matters podcast. I'm Richard Brock, and in this episode we're unpacking, figuratively at least, containers. Not the kind you find at the docks, but the kind that's quietly revolutionizing how we build, ship and scale software. Joining me this week is Ash to help us understand why containers matter, how they work, and what we gain when we organize our ships well. Let's set sail. Ash, you've been working with Collabora for about 10 years now, is that right?
Almost. Yes, closing in very quickly.
Amazing. And you've been very active in the open source world for quite some time, I understand.
Yes, it's quite interesting how, the years and the decades tend to roll by and eventually you're shying away from the big numbers, as it were. But I do enjoy contributing to the open source community, especially projects that have large impact. They have a big user base and they do matter in our quality of life and day-to-day activities. And at the same time, I get the enjoyment of solving fairly challenging problems.
So today the problem to be solved is containers and how do they work in software architecture, not in shipping. But I think it's perhaps helpful for us to start with shipping. Ash, as far as I understand it, the traditional way of writing software, sometimes called monolithic, is essentially you take all of your things, cars, furniture, whatever it is, and you throw it into the hold of the ship. And then you take your ship from A to B. Which sounds great, but as soon as there's a problem, if you want to get one car out of your ship, or if you want to fix a leak somewhere, if you want to upgrade your engine on the ship, it's a big problem because everything's all together. And then someone came up with this great idea of containerizing everything. So everything is neatly packed into standardized containers. We've got cars here, we've got furniture there, we've got food here, all the different services of your software package are all containerized. You can move them, replace them, you can add them without disrupting the others. Is that about right? Is that what's going on?
Right.
Help me out.
I think that approach is useful. The way I think about it is traditionally when you needed to run a service, you would have a dedicated machine, a real physical hardware that you needed to have physical space for, a real estate, and hook it up to the power lines and connect it to the network and so on. And that works. It worked fine. It works to this day. The problem with it is it's dedicated, and it is dedicated to a single service. If you need to share that hardware to maximize its utility, then you quickly run into issues. One obvious issue is that different software packages have different dependencies in terms of what libraries they need and what assumptions they make about the operating system and the kernel, etc. And these requirements might be out of sync with one another, meaning they don't necessarily need to be the same. The developers who work on these and the firms behind them might not necessarily see eye to eye on technical details. Ultimately, what you have is a maintenance challenge where upgrading one service might impact others, and you also have concerns about side effects and things like that. This is where containers really come in and shine. Think of them as lightweight packages, if you will, that you can run independently and shut them down at any point, and indeed upgrade and move between versions as necessary, independent of the actual host you're running on. So now you have independence of hardware resources and real estate and all the other considerations from the services that you're running, which versions and how you upgrade and how often. You're no longer tied to the hardware, you're no longer tied to the system, and you no longer need to worry about compatibility across services.
So let's talk about scalability again in a minute. But to try and make things a little bit more concrete, perhaps, for our listeners. So you work a lot with Collabora Online. It's a document editor. What does it mean for a system admin when you say that these services are containerized and that helps them with their upgradability or their compatibility with different services? What's that mean using the example of a document editor?
To put it in more concrete terms, let's imagine the document editing functionality or service is often complemented with storage facilities. So you'd need some storage management, you would need the storage services as well. These are independent of the document editing version and features, etc. And you would probably want to manage them separately. As a good example, scaling the storage, meaning adding more storage devices, is fairly independent, and you would want to have the flexibility to do that independent of how many instances of the Collabora Online service that you have running, which is for editing documents. That in turn, the Collabora Online instances would depend on the number of concurrent users that you expect to have on a typical day. So if you provision, for example, that you'd have, let's say, 10,000 potential users, say, 300 of them might be concurrently editing documents at any given time, working on, say, 200 plus documents, then that provisioning has nothing to do with your storage needs, right? It only has to do with the resources for editing documents. And the storage can be multiple terabytes or petabytes or not, might be something even much smaller. You might also have services for email. Using containers, you can isolate them and separate them and get all those benefits while still maximizing the sharing of the hardware.
So if I understand correctly, this is really helpful from a performance point of view, and then perhaps also scalability. Maybe you can help me there. From performance, because by separating things, if, say, the document storage becomes very power hungry, then that doesn't have to slow down another service. We can move the other services onto some different server hardware and make sure that things are running at peak capacity, which then is to do with scalability. Is this
indeed
the right direction?
As we said, one major advantage to having containers is to have independence and isolation, so you don't have compatibility issues. So that makes upgrades easier. But the other aspect which you touched upon is performance and scalability as a result. That does have a small requirement in that you need to build into your infra the ability to isolate or separate the externally visible services. But once you've done that, you've designed your infrastructure and topology, as we call it, sensibly and flexibly. From then on, you can fairly easily move your containers from one machine to the other if you feel that one machine is becoming oversubscribed, overloaded, or you can add newer instances on other machines and have them take some of the load off of the primary ones, as it were, up to that point.
So then going back to the simple analogy that we started with, that's possible because it's standardized, all these dependencies. So we can get another ship to carry these containers. It doesn't have to be the same ship, but it just needs to be able to follow the same standards of the ship they're currently on. So it's relatively easy to get 10 more ships to do some more shipping, or equally to offload ships when we don't need them. We can rearrange our cargo
absolutely
as and when we need.
One major advantage that software has compared to physical devices is that you can copy paste as much as you want. So once you have a container image for a given service, you can, by copying it, replicate it identically. And that's the advantage of containers, where you are only replicating a single service with all its dependencies and all its configurations, etc. And you're getting an identical copy of it. So now you can run it on other hardware in parallel and expand your capacity that way, get better performance as a result, which is what we call scalability, because you're scaling your capacity with your needs with your number of users, with their usage and utilization, and so on. This is in stark contrast to being in a situation where you have a box, a machine that has all the services installed on it, and now somehow you need to replicate that machine on another one. Unfortunately, copy pasting just doesn't work in that case. You'll run into a lot of serious issues. And containers make that separation between the hardware and the software quite convenient. And again, all you need to do is just deploy from the same image and you get the same service with the same configuration, same exact version, same exact dependency. So you have confidence that what is running on one machine is identical to the other one, and there wouldn't be any surprises.
This might be a topic for another podcast, perhaps. So Collabora Online now has a Kubernetes controller, which does all of what you were just talking about, essentially.
Yes. That's the orchestration aspect of it. So once you have the ability to deploy Dockers and benefit from all these advantages that we've been enumerating, now you need an equally easy way of coordinating and managing your instances and deployments and how many boxes you need a service running on, etc., which is called orchestration. And indeed, Kubernetes would be ideal for such a need.
Maybe one last one to finish on. A little birdie told me that our containers are something called stateless, and that this is very handy for security. What do we mean by stateless, and why does this matter for security?
This is not a quick topic, but
we could talk about it more another time, perhaps.
Absolutely.
Give our listeners a teaser for the...
A teaser, indeed. So traditionally, when you have installed your services on the hardware that's going to be running them, any information that you need to preserve, you would need to write to the disk. Everything from configuration to which documents are being edited, which users are connected, authentication, etc. There are multiple issues related to this when it comes to security, not least that you don't have isolation, meaning if at some point there is a security breach and one of the users is able to sneak beyond their document limits and somehow try and access other documents, technically it is accessible because it is all on the same machine. You would wish that every document had its own machine, but then we know that doesn't work, that doesn't scale, right? Especially if we're talking about physical hardware machines. The advantage of stateless approach is that we can dynamically isolate every document and give it the illusion that it is indeed running on its own storage and it has its own view of the world. And obviously, if you have the Collabora Online service running in a container, then you have the container as another layer of isolation on top of the individual document level isolation within the service. And by having these multi-layered isolation rings, you have confidence in your security, because even if one is breached, you know the next one is going to hold.
It sounds like a much bigger topic. Perhaps we should be talking about stateless containers another time. Ash, thank you so much for helping me, and hopefully our listeners understand a bit more how containerized architecture works.
My pleasure.
We look forward to hearing from you more again.
Absolutely. Thank you for having me.